So first I'd like to thank Jay and the organization for giving me the opportunity to present and share with you the roadmap on AI that we have been working for the past year. And when Jay asked me to come here, he asked me to present the roadmap. But if I just present the roadmap, I will be finished in 5 minutes. So I squeezed in a little bit more to share with you the work we did behind the scene to support the roadmap. So basically, we talk about the roadmap in general, and then we talk more specific about how we move forward on the technological side to support the roadmap, mainly to find a path to certification of AI system that the industry will be putting on the aircraft. And I say this because that's the focus that we are having right now. We think that by focusing on one thing, we might be able to do well instead of looking at everything, and we might not be able to do well trying to cover everything at the same time. So the philosophy is to do one thing, learn about AI, and share it upward with all the policy makers so that we can expand the understanding to all the domain. So the industry in aviation specifically, we know about the importance of AI. We saw many development in R&D, and we even saw some application at the FAA for certification, and some of the independent product, they applied for product approval, which is equivalent to the certification, but is focused on one product only. A little bit about myself. I came over to the FAA in 2022. And when I came to the FAA, I met Andrew in the first week of another conference. He sat next to me and he told me I had an easiest job at the FAA because a lot of organizations already work on AI, and they already spent a lot of time working on AI standard. So all I had to do, what he didn't say was, what he implied was that all I have to do is just adopt whatever is in the industry and sign the approval. So that's the perception that people have on my job. But going back, before I joined the FAA, I was at the Air Force Academy doing research and teaching for the Air Force. So 2019, I saw on the news about Boeing announcing some smart drone that they developed for the Australian Air Force. And immediately after the news, I saw the media criticizing the FAA for not having any AI expert. How are we going to certify aircraft with AI in it? So we are looked at like a roadblock for innovation. So that's why in 2022, the FAA has an advisory committee called REDAC, Research Engineering Development Advisory Committee, that gives us direction on what we should do. Of course, it's a recommendation, but we listen to them very seriously. So they make the recommendation that we start working on AI to provide a path to certification of AI technology. So the industry will know that there is a direction. They will feel comfortable investing to put AI component on the aircraft, knowing that the FAA can certify it.
By the way, I was on the REDAC SAS.
Yes.
So,
Yes. So thank you. And again, I think I made a joke about you provide a job for me on that recommendation. So I was hired away from the airport, working on the AI roadmap But so after about a year in 2023, we started working on the roadmap, and now we publish it officially in August this year. We finished it when I proposed to do a roadmap. I looked at some other roadmap. So when I started working on the roadmap, I looked at some other roadmap, 25 pages. How hard can it be, right? So I proposed to read that maybe about 8 months. I thought I would be able to finish it in 2 weeks and then put in the question to handle Murphy law. But we finished it at the beginning of this year because we wanted to get involved with the industry, and we also wanted to get involved with everybody within the FDA as the consensus approach. And you know what? I learned a lot about the consensus approach. I knew the definition is about working together, but when we use it, we got a lot of help from everybody from the industry to help us. So that is the meaning of consensus approach that I learned. So we published it in August this year. And what we plan to do is immediately after the roadmap, we want to publish technical paper to support what we want to do in the path to certification. But a little bit of perspective, we saw our counterpart, EASA, had a roadmap about 4 years ago, and they updated the roadmap into version 2.0, and they have 2 technical concept paper to support their roadmap. We can talk more about the differences between us and EASA, but we like to do the same thing to provide a clear getting a path to certification of AI technology. The difference is that we are more focused with one thing on board aircraft software that has AI in it, whereas EASA, they try to do everything. That's not a bad thing, but it will take a lot of time to do. So what we want to do is we are playing catch up. So we want just to focus on one thing at this point. So for the roadmap, 25 pages, we only have 3 things that I'd like to highlight. One is the focus that we have will be on software that people put on board the aircraft, specifically AI system in the form of software. And we have some guiding principles on how we move from here to the point that we can certify the aircraft with AI software. And in the background, just like EASA, we invested some money on research. We don't have as much money as EASA, but we try to make do with it, the money we are given. And I will discuss that more, how we stretch the money on research, but mainly to support the certification of the roadmap of AI technology. So the first thing I want to mention is, I cannot read what I put there, but the first thing is that we put focus on safety. This is an important aspect. If you see the executive order on AI, you will see that it covers many aspects of AI, but mainly for the use of AI across government agency. Here, we only focus on the AI system that people put on an aircraft to do one specific function. For example, when we look at the recognition software, it's a smart system. If you train it to do recognition of the face, and if you use it in criminal justice, for example, to recognize suspects and track them down, then there is an ethical side that you have to make sure that the software is not going to be perfect. You train it to do a job, it will have some error, and we want to make sure that the error will be equally distributed across different ethnic groups, so that we won't target one group with higher rate of wrong recognition. But for us, when we look at safety, I'll go to the next point. We don't want to personify AI. So when we look at the AI system, we see that as an engineering component. So we handle it just like any other engineering component. So going back to that facial recognition solution, now I saw people apply that to recognize the airport, recognize the runway of the airport. You probably read some news about pilot falling asleep, woke up and land the aircraft at the wrong airport. I think it's Houston, where we have 3 major airports, and the pilot, I'm not allowed to say which airline, but they land at the wrong aircraft. So there was talk about, can we put a recognition software to recognize which airport the pilot is facing so that he can land it correctly. In that use of AI, we ask ourselves, do we need ethics, or do we just need to establish minimum performance, just like any other piece of engineering component? So if the software meets the minimum performance, then we pass it. Just like medical doctor, you go to see a medical doctor, you don't care, you don't even know if he made a C when he was in medical school, the minimum performance. He treated you, and the same thing with engineering aspect, minimum performance. We don't care if the software has better recognition with the Dallas Fort Worth International Airport, better than the low fuel. As long as they meet the minimum performance, we think it will be okay. So that is the aspect of looking at it as an engineering component. And we saw a lot of people talk about AI in the area of research. And for research, everybody can dream what will be happening in the future. We are looking at now for policy, something that has to be compliable, not something based on research that might or might not have a solution. So in this aspect, we saw an AI system that we train, and then we lock it to make sure it's deterministic and we know how to handle it, and we will manage it for now. People talk about letting the AI system to continue to learn even during operation. We need to understand the behavior of the learning, which we don't know yet, we don't understand yet. So we want to make a differentiation. We are going to handle the learned AI system now and working very hard in the background for learning AI that might be coming very soon. And one key thing about us is that we have a good safety record. I know once in a while you see incident happen, like some aircraft blowing off a door, and then people start blaming on the FAA. But if you look at the overall history of the FAA, you see that we have good safety record, and that was dependent on the existing regulation that we already have. We don't want to reinvent anything hastily. We just want to use as much what we have now with a little bit modification because of the new technology. Here, when people ask us about what is AI, definition of AI, I started learning AI exactly 40 years ago in 1984 when I was a student. And the definition back then was a discipline that mimics human intelligence on computer level. So since then, people criticized that definition because it wasn't vague, about what is human intelligence. So the definition evolved, and you see from the executive order that President Biden signed last year, it specified AI as a function that human can do. For example, we can generalize the data, we can use the generalization to predict things, and you can see a listing of functions associated with human intelligence on it. So it's more specific after many years of evolution. But one thing that doesn't change is that it's implemented at the computer level. It means that it's a piece of software. It got to have some algorithm. It's implemented on a traditional computer. So what's a big deal about it? So that's what we're looking at, AI as a piece of software. So we are going to use existing guidance for software and just a little bit because it's developed differently. So I will spend more time talking about that on the projects behind the scene near the end of this presentation. And we are very humble. We don't claim that we know everything. So we're going to go from one specific project so that we can have better understanding before we extend it to a general policy. So at this point, we don't have a general policy yet. We're working with policy group from the FAA to have better understanding, and we hope to put in some policy statement on the schedule of the AI roadmap by the end of this year, and policy will move forward next year. And we are going to look at the system with low criticality, low risk, so that we have better understanding. And then we try to look at it from many aspects, and before we decide what is necessary to regulate. So at this point, we look at AI at different aspects, and this is different from the executive order that cover every aspect of use of AI. So that has been handled by the National Institute of Standards and Technology, and at the FAA, we have an AI strategy how to comply with that. So that is different from the roadmap to certification path. And the final thing is the collaboration. We work with the industry, we work with many government agencies. We want to stress the value of the money we are given. So we work with NASA, we work with the Department of Defense, and we work with the industry mainly to move forward. Industry typically provides projects. Some of them work on products that they felt is ready to put in the aircraft. Some of them are doing research. They just want to make sure that we at the FAA know how to handle the technology. So they are providing us a lot of proprietary information to help us develop the policy later on. So since I have 10 more minutes.
Sure. Yeah.
So what we have now within the FAA, the most urgent thing is to establish some standard that the industry can use. I mentioned earlier when I met Andrew, he mentioned that there have been work on standard development for the past 4 years. We look at them. Fortunately, we have a lot of experts, but unfortunately, they look at the standard from the automation point of view, and everything was about the safety concern for automation, which we don't have in the operation of the aircraft yet. We don't even have any plan to do crew reduction. So for automation roadmap that we saw from our counterpart, EASA, we think it's a good path to the future, but there's a missing link about what is now that we have to fill in the blank. So we want to establish that standard now with AI technology. So we plan to publish technical paper that I mentioned earlier, and I will describe that more. And we want to show some use cases. My background for the past 20 years was in academic. So everything we talk about, I want to have some example that people can see how it works. So we ask the industry partner with us to provide use case example, not about the system they develop, but the steps that they have to work through to satisfy the certification requirement that we are investigating now. So we are asking our partner, and we will have a meeting next month, November 14 and 15, where we will be presenting the technical concept paper, how we handle AI, and then we will have the industry to present use cases. One is NASA Ames Research Center. Another one is Honeywell, who collaborate with us on research. And we have GE, who is working as a contract researcher for us, and they will be presenting the backup plan. What happens if what we're looking at doesn't work? So they work on a backup plan on how to certify AI. And we want to participate in as many forums as possible to promote this work. And that's why one of the reasons why I'm here. Another reason I have an office here, so it's very convenient for me. So the work in progress, we look at the guiding principle to decide what to do next immediately. One thing is that we want to treat AI as an engineering component. And another thing is that we want to look at the current technical team, and we saw the machine learning as the core where people have problems with, not from the development point of view, but from the certification point of view. So the two technical concept paper we have is nothing new. It's about things that people discussed 5 years ago when they started the conversation on AI. They recognize that there is a gap that we cannot handle AI algorithm within the existing guidance on software development DO 178C. So we identify that we have to do some sort of verification of the AI system outside the software implementation. And then after that, we will do the verification of the software, not on the AI system again, but on the implementation of that system. There's no point of doing double verification like you see in some description. So in November 14 and 15, we will have a very draft document on the verification of the AI system. We will post it on the internet for everybody to review. Again, I saw benefit of doing the consensus approach from the roadmap. So we're going to share with you everything that we have, even in the draft, that you will see a lot of my grammar mistakes. So I will share with you, hoping that you can help with the effort. So here's the problem for machine learning. I kept seeing that as a modeling technique that begins with having a set of data, and the developer will have to select a model, in this case, the artificial neural network, in terms of how many layers he wants, how many neurons per layer that he wants to put in there. So he had to select that, and then he will have to optimize the model with the data and get a learned system. You see that I stay away from the terminology in AI, ML, and when when I have more time, we can talk more of why it happened. But it happened because they use it a lot and cause confusion, and sometimes they can cause misdirection, especially for many things we already have the engineering terminology. So I want to use engineering terminology to reach everybody in the engineering community. So here's the issue with machine learning. We begin with data, and we don't have any specification of what the model should be, like in traditional engineering development. When you are doing a design, you are giving specification or put it in the form of requirements that people can verify later. With machine learning, we don't have that. We just say, here's the data set, go and do something, click a button on the training software, they will produce the optimal model for you. So in that aspect, the developer can say that they have a model, they test it a few times, it seems to work, but they could not explain how it works or how well it works. So that's the major problem. If we try to do the verification with the existing BO178C for software, then people talk about where is the requirement. How are we going to verify the requirement if we don't know what it is? So here's the approach that we have. This is described in the document that I will share with everybody in about a week and a half. What we see is that the specification is there, is embedded in the training data or modeling data. It's not explicitly spelled out to the developer, but it's there because it's a guidance so that the system can be developed. So that is the important thing. If the information is embedded in the data set, we want to extract that information, and then we want to put it in the form of the requirements that the engineer are used to see. And if they see the requirement in the form that they are accustomed to, they are trained to do, to verify, then they will say, aha, I know how to do it. So the important thing for us is to extract the information from the data set and then put it in the normal requirement format, and everything else will follow BO178C to do verification of the model at the item level. Every discussion that you see now in the community is about safety concern, and it's not the first time people have safety concern with engineering components. We have a library of all the regulation that can handle that. So there's no reason to reinvent how to handle safety concern of an engineering component in the aircraft. We just want to make sure that there's just the missing thing in the path to certification. So we are providing the missing step of verification of the model that people train or develop. So the final thing is the research that we have. We want to work to provide means of compliance to what we're looking for. So this is an important aspect. If you see some other discussion, people speculate what will happen in the future, and they said that the means of compliance is anticipated for the future. For policy development, we cannot do that. We have to have means of compliance that people can comply with what we are asking for. So that is the important point that we do in research background. But at the same time, people at the FAA, managers, directors, they see the potential of AI So they asked ourselves, we asked ourselves, can we use AI to improve safety? So what we're looking for is some beginning to investigate. And one project that I just started is looking at the accident report database that was filed by human, and we try to use the large language model so that we can unify the language theme used by different people, and we try to have it in a standard form. And then what we are going to do is we're going to apply data mining to identify different types of accident. And for each different type of accident, we can study to investigate the trend or what happened as precursor to accident, so we can identify early warning sign, and we can prepare some course of action or recommending some course of action to the pilot. So this is one project that I'm working on right now. My manager went to too many demos. People promised too many things, and he kept telling me that they already did this type of experiment. We heard of the demo, people trying to sell us software. They said that you can use this, and then some people bought a piece of software because the hot thing right now is the large language model that people saw with ChatGPT. So they play with it, but the reality is nobody ever have anything yet to show. So we just want to show the technological demonstration that it can be done and it can be used immediately, and so that people can have confidence how to move forward with the use of AI in different aspects. So on the supporting research, this is documented in our research strategy, but at a lower right quadrant, you will see some target bit. We try to have the ability to certify AI by at a low level of criticality. In specific terms, they call it LAUC as a low criticality level. We try to have it done by the end of 2025. We prepared this last year. I thought 2 years was a long time, but I'm seeing that now I have a lot of pressure to do that by 2025, because now we are at the end of 2024. So the final thing I want to mention is that AI, through the eyes of the media, is a new technology, and they hype it up. A lot of people work on AI. They like to feel important, so they hype it up. So we look at this hype curve of new technology, and what we felt is that along the timeline, this is where we are now. We still see a lot of hyping of the technology that it can do almost everything if you just train it to do it. So that's where we are. What we see is that unrealistic expectations set up a lot of unrealistic course of action. And we saw a lot of that for the past 4 years in the conversation with people trying to develop standard for AI. So what we want to do is that we want to go from now to the point that we can work together, that they call a level of realistic expectation, so that we can start to be more productive and work on what has to be done. Right now, if you participate in a lot of forums, you will see the discussion on AI branching off in many directions. So at the FAA, we like to work with everybody to have better understanding of AI, and we work with our government agency, NASA. I had a meeting with NASA at Langley about a month ago. They wrote into their budget some project to support the FAA. So we are taking advantage of the additional help So anything that can help, we welcome it. Even one company who applied for project approval, later on they show that it's not about project approval. They wanted to expose the FAA to AI technology as early as possible. And that has helped us tremendously on the certification side. So thank you for,
Thank you.
for your patience. I'm sorry.
Questions? I wanted to ask one thing. You make the distinction, and I've seen this before, between learned and learning systems, and you'll certify the learned system because it's deterministic. But a lot of the power of AI is in the continued learning. So is there a pathway for a company that would say, collect the data that would continue training on an electronic twin or something? Is there like a way to update the system and instead of going, starting from scratch in the certification process?
Yes, we talked about this 40 years ago, and at that time, my background was in control theory. So we talked about designing a PID controller, and then later on, people figure out how to do adaptive control and then update the gain constant of the PID controller. I play with it. Immediately, the first adaptive controller that I designed fluctuated a lot. And we looked at it, and then at the time I started to study AI. So we talked about the meta rule, the rule governing the learning process to make sure it's converged. That is something that we are still studying now. And I work with companies on the learning AI for the future. But there is one intermediate step. People buy AI software that was trained by some company as commercial off-the-shelf product. And then they train it a little bit more. So they ask us, how are we going to certify that system? How are we going to understand the performance of the system? When we first part of the training data, it's not available. They can only provide the second part. So that's the intermediate step. And at the same time, I always go back to adaptive control to see how we broaden the adaptive control in the aspect of AI. So that's the background that we're working on right now. And the urgent thing is one company already bought some commercial off-the-shelf software, AI software, and they train it more. So we have to come out with some certification path where we only know one portion of the training that they fine-tune the performance. The first part of the training data is locked by the original developer. They claim it's proprietary information. So we are working on that project as an intermediate step before we go full path to the learning AI.
Oh, go ahead.
Oh, sorry.
You were talking about large learning models, and you were talking about some problem. I missed making a note of that specific point. Do you mind going back a couple of slides? Probably after that, yes. Okay, let me try my question. Go ahead, Andrew, and I'll
Oh,
the question.
Now I'm forgetting what I was going to say. No, something that you said, Jay, that a learned AI model is deterministic. I don't know that that's the case. It's still a probabilistic model that may have limited explainability and traceability, which adds to the complexity of verification. It may not be changing. The model is static,
Yeah.
but the model
You're
still
correct.
is not transparent. And it uses the probabilistic technique. So it's a walk, crawl, or crawl, walk, run. Let's start there, I think is the right move.
One thing that I mentioned in the paper draft home about the idea of the model being stochastic or deterministic. So we look at the definition from Wikipedia. We saw that the model has a specific definition of linear combination of inputs passed through another well-defined function that we call activation function. Every time we pass one set of data in, no matter how many times we pass it, we always have one unique output. So that's the deterministic aspect that we're looking at, so that we can verify the output.
But the traceability is not there. The behavior is repeatable.
Yeah.
That is different. Repeatable behavior is different than deterministic in my mind.
Well, we can talk about Wikipedia later. But
Well,
that's
there's also, we did a study at the National Academies, I think it's about 10 years now, about AI and autonomy and aviation. And we specifically, we're wrestling with this very same issue. What are the differences between determinism and what are the sources of non-determinism? And one source of non-determinism is the stochastic nature, but it's not the only source.
I know, I'm just giving it as one example to differentiate from deterministic system.
Amen.
Okay.
Yes.
So if we look at that point of view, the output is guaranteed to exist when you know what is the input range. In software, we call that intended behavior. So what we're looking at is to understand the intended behavior so that we can guarantee that it's in that area, and we can certify the output to be as expected. And what is outside the intended use, we know that it will produce the output. It's just that we're not going to say that it's reliable on that area. So just imagine a simple one input, one output system, so that you see that if you have your input going from 0 to 50, then that's easier to define the completeness of your data across that domain from 0 to 50. You guarantee that the output will be deterministic as expected. Outside, we don't have any data to train, so it still produces some output. It's just that we know it's not reliable because we have no data to specify what it should be. So that is the aspect that we develop when we try to look at the verification of the model within a well-defined domain. And we can talk more about the philosophy. I can send you a graph that I have now, so you can see the discussion about deterministic versus stochastic. We might not agree, but we specify that we have two types of discussion of AI. One is the engineering discussion, and one is a philosophical discussion. And we'll see.
I'll just take a minute. I read this work that is ongoing for a few months ago. In fact, I reached out to a field and talked to some of the people who are working in this. I think the point that you mentioned just now, the idea of, for example, bounded input and bounded output, that could be at least a starting point for coming up with this kind of deterministic, somewhat deterministic.
Yes. In traditional modeling, for example, linear regression, what they have is they have a line as a model, but then after they design a model, they look at the residual error, they analyze the statistical distribution of the value of the residual error, and then they calculate what we call expected error. The reason we are using model is not just to fit with the data, we are using it later on to predict something that might happen. And that prediction has to have some bound of the accuracy, and we cannot use calculation of the addition of all the residual together. We have to calculate the expected error, and then that expected error is an estimation, so it has some error in it. So we're looking at the bound to have a more conservative bound that would say the error will happen, up with the upper and lower bound. So that is the statistical aspect, but the model itself is not statistical.
Thank you very much. We'll probably need to. Oh, okay.
I have my email here, so if we miss your question, please send me an email and we can comment.
Thank you. So one of the advantages of setting the agenda is you can put yourself on them if you want. So I did. And when I realized that Dr. Pham was going to come here and talk about AI, I wanted to talk about some of the work that I've been doing. And I'm going the wrong way. On meaningful human control of AI-based systems. And what are we talking about here? In 2016, the UN had a meeting of experts and decided that meaningful human control was required for autonomous weapon systems. Okay, but they didn't define what that meant. And in 2018, NATO's Science and Technology Office, STO, stood up a Human Factors in Medicine panel, HFM, to look at an exploratory team exploring the human system aspects of meaningful human control. And that involved into a 3-year task force and developed a technical report that I'll show you in a minute. Oops, keep going the wrong way. I turned it around and forgot. Okay, but why do we care about meaningful human control? One is system performance. Algorithms aren't perfect. Sometimes we need to have some people in that system. Autopilots on cars, not perfect. Sometimes we need to have the human judgment come into the system. We don't probably want AI-based systems making moral and ethical judgments. And in fact, there are, and these are in italics here if you can't read it, but there are times when maybe even compassion and human intuition is important in these systems as we go forward. So here's a couple of examples to hopefully motivate this. This is one you probably heard of. It's called, there was a movie made about this, A Man That Saved the World. 1983, this nuclear, or this Russian lieutenant colonel, I think, was in charge of the Soviet nuclear response. They got the warning that they'd been launched against by the United States. All of the protocols were to immediately fire back, but he followed his feeling. He felt like something was wrong. He didn't think that this made sense. He followed his gut decisions, maybe his intuition, and didn't fire until he got further information that showed that this was a false alarm. This is a pretty hard thing for an algorithm to do. An AI-based system is not going to get a gut feeling that it just doesn't feel right and something's wrong, right? So that's one of the examples. Another one is, this is out of a book called An Army of None by Paul Scher, and I highly recommend this book. It's really, really good. He was a special ops recon team leader in Iraq and Afghanistan. And one example he gives, there's a young girl, 5 or 6, headed out to do some with some goats to herd the goats, and ostensibly she was just doing that, that job, but actually she was spotting for Taliban fighters, and they did spot a radio in her hand. They noticed that she had that, but they still decided not to fire, even though under the rules of engagement, they could have and probably should have, in some sense, fired at her for the safety of the team. Again, this is sort of, when one of the problems that AI often has is when you have to break the rules, when you decide, here are the protocols, here's what's going on, but I'm not going to do that anyway. It's like, you know, the autonomous cars that have trouble going over a double yellow line when a flagman wants to flag them through because of construction zone. It's one of the more difficult things that they do. So there's a couple of these examples that I think are really important. But I think there's also, you know, this all came out of sort of autonomous weapons and that kind of thing. But I think there are civil applications. And as soon as I started sort of delving into this, you start to see them. I think in autonomous cars and in autonomous air vehicles, you see some of these things start to come up. And I think we need to at least, and I don't know, I'll reiterate this at the end, at least investigate and be aware of the decisions that are being made and ask ourselves if we want a human in that loop. So this is the panel that got stood up. Mark Draper from AFRL and Jeroen van Diggelen from TNO in the Netherlands as an AI guy, so it was a human factors guy and an AI guy. And we had reps from France, United Kingdom, Germany, Sweden, Finland, Netherlands, United States, Italy, and Australia. So it was a nice group. Some folks that have been working in this area for a while. And there's so many different aspects of it. There's legal aspects, and human performance aspects. We had a number of workshops, invited speakers. We had a couple meetings a year for 3 years, and developed scenarios in which we could go through and ask ourselves, where are the decision points? Who's making the decision? And do we want, is there a way to have the human in control? We came up with this definition. So it's very difficult in these international groups to come up with definitions that everyone agrees with. But it's basically the ability of humans to make informed choices that lead to the outcome, to a positive outcome of a system. So that to influence the AI-based system to get a desired effect. And one of the keys that comes up right away is, well, a lot of these are highly time-dependent systems. They're making a judgment that only takes seconds. But so how can you have a human in the loop? Well, you can still by having working agreements, or some people call these advanced directives, where in the design process you say, it's sort of the if-then. If you have 95% confidence of this and you have 95% confidence of that, you can go ahead and make that decision. And so there are ways, to have a human in the loop without being in real time. And here's a DAA example. Detects an aircraft on a course or still an unacceptable point closest approach, and no action is taken, and then the PCA will occur in 20 seconds, then perform the evasive maneuver. So this is meeting a few conditions before it actually takes over and makes the maneuver. This is an important one, I think. We tend to think about AI systems as one system, a chat GPT, that kind of thing. As we get into more of these systems, they become systems of systems, and we have embedded AI that we don't even kind of know about. And if you have AI systems in the perception end, for example, which is a lot of times where they go automatic tracking, facial recognition, automatic target recognition, those kinds of things. And then that information is then passed to the human to make a decision. It's already been biased. It's already been processed by maybe more than one AI-based system before it gets to you. So you really need to, I think, go back and look at how these decisions get made and whether or not they need to have the human more in the loop. So there are some guidelines for responsible AI that have been published: lawlessness, lawfulness, responsibility, accountability, explainability, and traceability. These ones in red, I think, is where this comes in with meaningful human control, reliability, and governability. You need to be able to have control of this. And as we all know, the explainability and traceability is tough. With these neural network systems, there is a whole branch of AI called explainable AI, but it's not not widely utilized at this point, but those are things that we need to understand. I know you can't read this. This is the cover of the technical document that's coming out. I hope, like in a week, I've sent in my my public release, and so this will be a NATO SDO document. And if you contact me in maybe a month, it'll probably take a month. I'll be able to provide this document to you. And there are guidelines in there, all the scenarios are in there, a lot of discussion. And so really quickly, I just wanted to make you guys kind of aware of this area and think about it. And what can we do with this today? One is be aware. There are programs like Manprint that the Army implemented that said, all right, you got to do human factors. And we all kind of in the human factors world kind of thought, well, that won't work. But just being aware that they have to do it and going through the process is useful. The same is true of medical devices that the FDA designated that anything that the consumer uses has to go through a human factors approach. But be aware of it. I think just like the scenarios that we built, we went through and looked at each of the sort of decision points. And I think in our systems, as we develop them, we need to do that. We need to go through and look at the decisions and how they're being made, why they're being made, and explain. Can we understand the explainability and traceability of that? And as I said, there are a lot of these systems are going to have embedded systems that you never even see or think about. And we need to be able to map the AI that's in those systems so that we can understand what we're trying to control as we go forward. And then I think the thing that we often do is develop these worst case scenarios. How can things go wrong, and trace the decision making within that, and see if we can understand where we need to implement meaningful human control. Okay, I wanted to be quick and get us caught up a little bit. Any questions? Okay, so we will take a break. It's 3:05. Let's come back at 3:20. We had a little slop in the schedule, so we're going to be okay.